Welcome to this presentation. I am David, an R&D engineer at Keysight Zurich. I'm going to present you the AP5022 high-performance multi-channel signal generator and its fast switching feature. I connect to this high-performance signal generator using our convenient signal generator graphical user interface. I'm connected to this signal generator and RF is currently turned off. If I enable RF, we can see the CW signal on the spectrum analyzer. To use the fast switching feature, we usually use sweeps, either stepped frequency sweeps or flexible list sweeps. In this case, I will show you how to work with a frequency sweep. I enter the Sweep and Frequency Sweep tab and configure the sweep as desired. In this case, I will start at 5 GHz and do 4 points up to 20 GHz. So I set the start frequency to 5 GHz and the stop frequency to 20 GHz. And then select 4 points. Now, to really show the fast switching feature of the unit, I will go to the timing limits of this unit. This particular unit has a step time of 30 microseconds. That's the fastest switching time we can get. Out of this 30 microsecond step time, we have a transition time between frequencies of at least 15 microseconds. So if I generate a sweep with a dwell time of 15 microseconds and an off time of 15 microseconds, that hits the timing limits of the unit. I entered the 15 microseconds dwell and off time and can now start the sweep. On the spectrum analyzer, we can now see how the unit switches through the pre-programmed frequency points. We have 4 points from 5 to 20 GHz. That's 5, 10, 15, and 20 GHz. I will now configure the spectrum analyzer to verify the exact timing of each point. To do this, I will turn the spectrum analyzer into zero-span mode. Set it to 5 GHz to look at the first point of the sweep. Reduce the sweep time such that we see one single sweep. So we can now see how the generator generates this 5 GHz pulse of 15 microseconds width. So if we want to capture the precise timing of all points in the sweep, we can use the trigger output of the signal generator. I go to the low frequency output tab, where I can find the trigger output configuration. I enable the trigger output, and this lets the signal generator generate the trigger output pulse whenever the sweep returns to its first point. Going back to the spectrum analyzer, I can now select the external trigger. So we can see that the spectrum analyzer starts its capture exactly when the sweep restarts. We can now see the first pulse of the sweep right after the spectrum analyzer starts its sweep, and we see the sweep repeat after 120 microseconds. On the spectrum analyzer, I can now hold this trace and use further traces to verify the timing of all the individual pulses. So we can now see that we get this precise 15 microseconds pulse width and 15 microseconds space for both frequencies, 5 and 10 GHz. If we go through the sweep, by adding further traces. We can now see the complete sweep, sweeping from 5 to 10 to 15 and 20 gigahertz. And we can verify the precise timing of this sweep. For an analog signal generator, a switching time of 30 microseconds is excellent. The fast switching capabilities of the 5022 are very useful in applications like radar, where we often have to simulate scenarios with different pulses carrying different frequencies and power levels. And thanks to the fast switching capabilities, we can achieve very good pulse densities.